Factory IoT monitoring system, and the team members are Gauri IS, Emertxe, Likita D, and Likil Venkatsai Murari Shetty. So, coming to the introduction part. Introduction. What does it do? First, monitors temperature, humidity, vibration, and machine status. We are using two Arduino nodes covering the production line and warehouse. Publishes the sensor data every 5 seconds. Enables remote relay control via ThingsBoard dashboard. Why we need this? Because it helps us to remotely monitor the sensors and also monitor the complete status of the production line and the warehouse, where the production line helps to manufacture the goods and the warehouse helps to store the goods. If we are not able to monitor these things, they might cause some trouble. Mainly, it eliminates the blind spots in factory floor monitoring. Automated threshold alerts prevent equipment damage, no physical presence needed for equipment control. It also enables data driven predictive maintenance strategies. And how are we going to implement these? The tools we are used for this are Arduino IDE, PiximLab, and ThingsBoard. Arduino IDE is a compiler where we are going to compile the codes. See, this is the initial page of the Arduino IDE. Here we are going to run the code, and then we are going for the tools, manage library boards, and select the Arduino Uno board. Once we select the Arduino Uno board, when we correct it, it shows the port and we also have to select the port. After selecting and compiling, we go for sketch, export compiled binary. And once we do that, we are going to save it in the same folder where we save the Arduino file. Once it is done, we are going to save the file and then again, once again, we have to compile, verify and upload. So the second tool we are going to use is the PiximLab. A PiximLab is a simulator, a virtual simulator where we are going to do the connections virtually, so it is helpful for the future for real connections. So this is the initial dashboard of the PiximLab. So once we go here, we are going to have the new file. We are going to load the hex file and boards. We are going to select the Arduino Uno board. Okay. Now the virtual terminal here shows the serial monitor and also how to import the tools in PiximLab. So in the tools we are in the modules we are going for the spare parts. Once we open the spare parts, it redirects it to the another page. Here we are going for the inputs, outputs and others. Like inputs means it all shows the input devices like DHT22, temperature sensor, LDR sensor, keyboard, potentiometer, push buttons, ultrasonic sensors and all. And the output, it displays like actuators like LCD, LED, relay, stepper motor, display buzzer and all. And the other are some additional devices like storage devices and converters. So the next tool we are going to use are ThingsBoard. ThingsBoard is a MQTT dashboard where we are going to display the data in a widget format, and here we are going for a unique dashboards. So let's come to a new dashboard. Here we have created a three dashboard: smart factory, warehouse and production line monitoring. The production line monitor captures the data from the manufacturing goods and the warehouse captures the data in the storage house. The both these data are then sent to the smart factory and creates a single dashboard where we can easily analyze the data from both the things. So coming next, problem statement. No real-time visibility. If we go without the IoT implementation, we have to constantly check the production line as well as the warehouse status so that the no goods are damaged. Delayed incident response. If something happens to the products, we immediately can't resolve the issue. So using IoT, we can easily resolve the issues from uh, remotely so that we can avoid the time. No remote equipment control. Once we are manually doing it, we have to go to the certain location and then control it via switches and all. Using IoT, we can easily control through the dashboard and maintain the system. Coming to the next, executive summary. So here mainly we are going to use two sensor nodes, three dashboards, nine telemetry keys, five terminal intervals, and MQTT reconnect. So the sensors we are going to use are DHT22 or LM35 for temperature, PIR for motion detection, LDR for light intensity, potentiometer, Arduino Uno as microcontroller. The data is then sent to the MQTT dashboard through internet. Then it process the data in the cloud and then to the application user. So this is the normal architecture of the IoT models, where first the sensor detects the data, then the sensor is sent the data to the dashboard or telemetry. In the application layer, it manages the data and shows in a representative format. In the web dashboard, we are able to communicate with the sensors. So these are the main files that we are going to use in our system. So next, my teammate Gauri is going to explain about the Node 1 implementation.
Hello everyone, myself Gauri IS. I am going to explain the Node 1 implementation where Node 1 is meant for the monitoring of the production line. Uh, production line. It consists of components like DHT22 sensor, push button, relay module, LED of green LED, yellow LED, red LED, vibration potentiometer, and LM35 virtual monitoring for the serial monitor, and finally Ethernet is used in the Node 1 implementation where DHT22 sensor is connected for the D, D2 pin. We can see it here. We can see the spare parts used in the Node 1 implementation. This is the DH222 sensor, PIR sensor, door reader switch, virtual term, LM35, LDR, and the three LEDs and a ventilation relay. And we can see the pin connections in the code. Here we can see the pin connections where DHT22 sensor is connected to pin number 2 and the LED is connected to 5 and yellow LED is connected to 6, red LED is connected to 7 and pin relay is connected to 4. This Node 1 implementation consists of a subfolders like sensor manager.cpp, sensor manager.h, actuator.cpp, actuator.h, configure.h, network cpp, network.h, rpc.cpp, rpc.h, telemetry.cpp, and telemetry.h, where sensor both this file of sensor is meant for sensing the data from the spare parts we used, and actuator is used to it consists of a relay and the LED. Configure.h is used to define all the pins. Network.cpp is meant for connecting the Ethernet. RPC.cpp is meant for response sending, and telemetry is also used for sending the data. We can see the telemetry in the things board. Uh, We can see the telemetry. We are going to visible all the values which are represented in the spare parts. Here the humidity sensing of 98.5 and temperature as 104.6 and machine status is 1, relay status is 0, sense error is 0 and vibration is for 1012. um, Next part is going to continue by my friend Varsha. Before that, I am going to present the dashboard that is in the production line. We can see the dashboard. It consists of a temperature gauge, humidity gauge, switches, relay status, machine status, sensor error status, and a time series chart uh, where temperature gauge is used to represent the temperature, and humidity it shows humidity changes, and switches is used to control the relay, and LED is meant for on and off of that, and time series chart is going to represent the data as per the time changes, and here we can see the graphical representation of the temperature and the humidity. We can see the temperature is showing of 105 degrees Celsius and vibration of 1012, and here are the numerical representation, and I am going to show the practical demo in the Pixim lab. I am going to change the temperature in the DHT22 sensor, uh, and I am also going to change the humidity. Uh, Here in the things board, we can see the changes in the dashboard also. See where the needling or changes, and the LEDs are also going to change, and we can do the on and off also. And we can also see the changes in our telemetry too. We can see the changes also which are changed in this values. Next is Varsha's. Hi, this is Varsha. Continuing with the Note 2. Here is my Note 2 implementation, which in Note 2 we are going to see the components like temperature monitoring, humidity by the DHT22 sensor, LDR by the LDR sensor, is dark is monitored when the light is off, motion detected when somebody enters the goods storage room, the motion is detected, door open, relay state, sensor error, and uptime. Here are the implementations of dashboard, which are analog gauge, which measures the humidity. Here are the analog and gauge of temperature. Value card, which shows the LDR value, how much light is sensed, is dark, whether the room is dark or light is present. Motion detected, whether any person entered in the room or not. Door open or closed. Relay state and humidity. And we're also going to see the alarms if any temperature changes of the one if any temperature varies from 30 degree where is greater than 30 degrees Celsius, then it shows the warning. The critical stage is 35 degrees Celsius. If the humidity crosses 70%, it shows the warning in alarm, and if crosses 85 degree, it shows critical humidity, and vibration is of 700 ADC, it shows warning, and machine temperature greater than 30 degrees Celsius, it shows warning. And here I am going to show you the Node 2 code, which consists of sensor manager, .h file and CPP, actuator, .h and CPP, config, network.h and cpp, rpc.h and cpp, telemetry.h and cpp. In sensor, in node 2, we are going to see all the we are going to initialize all the sensors, actuators, telemetry, network.begin, config.h, and all the other things which we are going to see here. In sensor manager, the sensor senses the data like pin, door open or close, LDR, DHT22 sensor, temperature, humidity, motion active or not. In actuator, it has been seen like LEDs, red, green, and yellow. We have taken pin of relay. We have taken config.h. We are going to initialize all the pin connections which we are going to do in Pixim lab. In network CPP, we are going to connect the Ethernet port to the things board to get the data transferred from Pixim lab to the cloud, which we can monitor anywhere where we are. RPC, in RPC file, we are going to control the relay state, and in telemetry, the data which is sensed by the Pixim lab or the DHT22 sensor has been transformed to the things board, which is a cloud platform where we can monitor all the data. Here is my node 2 implementation in Pixim lab. Here I am taken DHT22 sensor which senses the temperature, humidity, PIR sensor which senses the motion of the person, door reads which tells that the door, whether the door is open or closed of the goods storeroom, LDR sensor which senses the light, how much intensity of light has been there, ventilation relay, and here are the LEDs which I have given. With green suggests that if all the connections are correct and the data has been transformed to things board, then we can get the green LED. If there is any sensor error in the code, then I will get the yellow color LED on. If the Ethernet port is not connected to things board, I will get a red LED blinked. And in the V term, I will be there will be displaying of all the data which we get from the DHT22 sensor, LDR, and the PIR sensor and door switch. Here is my things board which transforms the data sensed by the sensors in my Pixim lab to the telemetry. Here is my warehouse, node 2. See, when I have here, the door switch is not on. So I have got the data as my is on. So I got the data as 1. Data as 1 in the door open, 0. So when I vary the humidity in the DHT22 sensor, so my data has been varied in the telemetry also. You can see here that 64.5. If the room is dark, that there is no light in the room, I can get 1. In LDR, the LDR value is also sensed, that is 3. You can see here. See, my LDR data has been sensed here. And coming to motion detected, there is no motion detected, so it has been 0. Relay state is 1. Sensor error, there is no sensor error in the connection which we have done, so the data has been sent as 0. And the temperature is also been sensed as 11.6. The same data has been seen as 11.6. Next, the implementation of dashboard. This helps to get the data like in a widget manner. Here I'm going to, we can choose a widget by going to edit mode here, add widget. We can add any of the widgets, any type of the widgets which we can get. So here I had taken the analog widget for temperature monitoring and humidity monitoring, the LDR monitoring, sensor error, motion detected, door status, and is dark are shown by indicating the LED lights. Here is the time chart. Here is the time series chart which shows the humidity reading. Here is the relay control. To control the relay, I have used switch control. And here is the time series chart to read about the temperature, humidity, LDR value, motion detected, is dark, door open, relay state, sensor error at one place. This helps me to see all the data at one place. But these can be seen according to only temperature can be seen here. But in here we can monitor all the data. You can see that here my data which is sensed is 11.6. The same data is seen in the dashboard in my temperature analog widget as 11.6. The same in case of humidity also it works on the same. You can see here my humidity is 57%. So the same reading has been given here. LDR value is sensed as 3, it's given. There is no sensor error, so the LED is off, that's in a red color, indicated in red color. Motion detected is, there is no motion detected, so given in red color. Door status is off, so red color it is detected. And there is a dark condition in the room, so the LED is on. All the data which are sensed here are again given here. And including both node 1 and node 2, that is production line and warehouse, we are going to see both the data in a smart factory which can be controlled, which the both can be controlled by a single person at any time. So the data from warehouse, that is node 2, and the data from the production line from node 1 are being seen in the same dashboard, that is smart factory dashboard. All the same data which are sensed in warehouse and production line are being copied here, and we can monitor the data real time. Here are the time series chart of temperature and LM35 which senses the same data. Next the PPT will be continued by Likita. Thank you.
As my friends have explained about the Node 1 and Node 2 implementation, now I'm going to give overview of our project. This project demonstrates how industries can be modernized and made more efficient through the use of IoT technology. Our system combines smart sensors, Arduino controllers, cloud dashboards, and automation features to create a complete factory monitoring and control solution. The main purpose of this project was to solve common industrial challenges. In many factories, monitoring is still manual, which means workers need to physically inspect in machines and environmental conditions. This can lead to delays, accidents, equipment damage, and production loss. Problems such as high temperature, humidity changes, vibration issues, and machine faults may remain unnoticed until they become serious. Therefore, industries need an intelligent system that continuously monitors conditions in real time and responds quickly. Our Smart Factory IoT monitoring system was developed as a solution to these problems. The system is designed using two Arduino Uno nodes. One node is installed in the production line section and the other node is installed in the warehouse section. Each node has multiple sensors connected to it. These sensors continuously collect important parameters such as temperature, humidity, vibration, motion detection, light intensity, and machine status. This data is then sent every 5 seconds to the cloud platform using MQTT protocol over Ethernet communication. One of the most important outcomes of this project is real-time monitoring. All sensor values are displayed on the ThingsBoard dashboard using live gauges, graphs, value cards, and alarm panels. Factory operators can monitor the entire system from anywhere using a computer or mobile device. This removes blind spots in the industrial operations and gives complete visibility of factory conditions. Instead of waiting for manual reports, management can instantly see what is happening inside the factory. Another major achievement is automated alerting and notifications. This system uses ThinkSpot rule engine to compare live sensor data with predefined safety limits. If the temperature rises above 35 degrees Celsius, a critical alarm is created. If vibration crosses threshold values, warning alarms are triggered. If humidity becomes too high, alerts are generated. These alarms help operators to take quick action before problems become dangerous or expensive. This improves the safeties, prevents machine breakdowns, and protect factory assets.
In the end, we thank the Emertxe company for giving this wonderful opportunity to work on the IoT platform. And also, we thank Ms. Jayalakshmi ma'am for teaching us about the implementation of IoT and basics of IoT. Myself, Likil, signing off.